Okay guys, in this video I'm going to do numbers 35, 36, and 37. Number 35, the directions are to find the GCF, not factor, just find the GCF. So we have to look at every single term and figure out what number can go into each of them and what variables can go into each of them. So starting with the numbers, we have 12, 6, and 18. When I see that, I think of the number 6 because 6 goes into all of them. Okay, then the variables, let's start by looking at the x. So we have an x squared, x cubed, and x. We take the variable with the smallest power, so that would just be x because x goes into x cubed. X goes into x squared. So we'll have enough there. So x to the first power, or just x. And then finally, let's look at the y's. Y to the fifth, y squared, and y to the third. Okay, since my lowest power is y squared, my GCF should contain y squared. And that's because, again, y squared goes into y cubed, y times. Y squared goes into y to the fifth, y to the third time. So my GCF is 6xy squared. Okay, you don't need to factor that out. If it asked you to factor, you would divide every term by the GCF and then have that in parentheses, but it only asks for the GCF. Okay, number 36, this one asks you to factor. So after we find the GCF, we'll have to divide. So first thing, again, is to find the GCF. In this case, the first term is negative. So we need to make sure our GCF is negative, okay? Whenever the first term is negative, your GCF is going to be a negative value. Now let's look at the numbers first. We have 10 and 50. The highest common factor between those is 10. And then our variables, x squared and x. X can go into both of those. Y cubed and y squared. Y squared can go into all of those. Z and no Z. So since the second term doesn't have a Z for us to factor out or pull out, there's no Z in our GCF. Okay, so that's the GCF. Now we have to factor. So we're going to divide every term by that GCF of negative 10xy squared. Negative 10xy squared. When we do that, we're going to be left with negative 10 divided by negative 10. Those cancel. X squared divided by x is just x left over. And y cubed divided by y squared is just 1y left over. And then we still have that z. Okay. On the next term, negative 50 divided by negative 10 is now a positive 5. X divided by x, those cancel. And y squared divided by y squared, those cancel. So completely factored, this would be negative 10xy squared times xyz plus 5. Okay, I know that some people may have gotten 10xy squared times negative xyz minus 5. And that is not correct because that first term is negative. So fully simplified would be a negative with a negative GCF. Okay. Number 37, there is an equilateral triangle. So that means a triangle where all the sides are the same, with a perimeter of 9x plus 12, and we want to find each individual side. So those three sides added together will equal 9x minus 12. Okay, well, if every side is the same, then we have 3 of these sides multiplied together, or multiplied by 3. Each side, or one side multiplied by 3, should equal our perimeter of 9x minus 12. Well, if I'm trying to figure out what the side is here, if that's what this missing box is, the side of the triangle, Then in order to solve for that, I can divide both sides by 3. These cancel, and then I'm distributing that 3 to all of the terms. So then I would get just the side of the triangle by itself. Kind of weird I'm using a word instead of a variable, but same idea. And then 9 divided by 3 is 3x. 12 divided by 3 is 4. So every side is 3x minus 4 centimeters. 3x minus 4 centimeters and 3x minus 4 centimeters. If you wanted to double check and see if that was correct, you could. You could check it by adding them all together, 3x minus 4, 3x minus 4, plus 3x minus 4, and seeing if that equals the perimeter. -4 plus -4 plus -4 is -12. 3 plus 3 plus 3, or 3x plus 3x plus 3x is 9x. So that checks out. So that means every side is 3x minus 4. All right. That was it. Okay, I'll try to check back and see if there's any more questions on the feedback form, but your test is going to be released very, very shortly. You guys can see my clock in the center in 6 minutes. So let's see if I can get this up in time.